everyone. My name is Abhishek and I'm mathematics faculty here at askIITians. And this is lecture number 3 of Applications of Trigonometry. We have already done the first two lectures. So let us quickly revisit the weightage of this particular chapter in both board examination and Olympiad examination. So as far as board examination is concerned, you can expect two questions from this particular chapter, and the net weightage of this particular chapter in board examination is going to be around 6 marks. And if I talk about Olympiad weightage, then in Olympiad examination, you can expect around 1 to 2 questions from this particular chapter. From this chapter I'm talking about, you will be getting few questions from the chapter that is introduction to trigonometry as well. So this chapter has good weightage, and the most important part is it is very helpful, and you will be studying trigonometry again in your 11th standard and in your 12th standard. So this forms a foundation for that actually. So your foundation has to be super good if you want to excel in mathematics in your senior classes. All right. So let's start with this. So in this session, the topic that we are going to cover today, we are going to do the problems based on inclined plane. Okay. So we will see the variety of problems which will be based on inclined planes. We will discuss how to do them, what are the things that needs to be kept in mind, and how you can use the properties or the concept that you have covered till now to do all those problems. So all that thing we are going to cover in today's session. Let's start. All right, this is an important problem that you have in your syllabus, guys. Okay, so what does this problem says? It says a contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meters. So basically, if you look at this figure, then in this figure, this slide this slide is meant for children below age 5 years of age. For slide for children below 5 years of age. Okay, below 5 years of age. Okay, and what else are we given? And is inclined at an angle of 30 degree to the ground. So this is the angle they are talking about. So this is the angle of elevation. Whereas for the elder children, she wants to have a steep slide. Steep slide is going to have more slope as well, at a height of 3 meter. Okay, and is inclined at an angle of 60 degree to the ground. So basically, this is the slide for elder children. Okay, slide for elder children. Clear? So then they are asking us what should be the length of the slide in each case. So basically, what do we have to find? We have to find here, we have to find ED, okay, and you have to find AC, because ED is representing the slide for the children whose age is less than 5 years, and AC is representing the slide which is meant for elder children. So let's see how we can do it. So we have 2 right triangles here. We have one of the right triangle is AEB, the other right triangle is ACB. So we are going to consider both the triangles one by one to get our answer. So in triangle DEB, because I have to calculate DE, which is acting as a hypotenuse in this triangle, I am provided height of this triangle. So I will look for the trigonometric ratio which involves height and hypotenuse, or in other words, perpendicular and hypotenuse. The trigonometric ratio which involves perpendicular and hypotenuse is sine. So what will you get? Like if you use sine 30 degree in that triangle, you will be getting dB, because that is acting as perpendicular upon hypotenuse, which is DE. All right. Sine 30 is 1/2. We all know that. The value of dB is provided to be 1.5 meter. DE we have to calculate. So what is the value of DE we are going to get? DE is going to be equals to 2 into 1.5, and that will be equals to 3 meter. Understood? That will be equals to 3 meter. So that means the length of the slide, which is meant for children whose age is below 3 years, below 5 years, I'm sorry, that is 3 meter. Understood? The same concept we are going to apply in the other right triangle we have. So if I talk about triangle ACB, in triangle ACB, if I calculate 10 of 60 degree, then 10 of 60 degree will be what? That will be equals to AB by AC. AC I have to calculate. I'm not aware of that value. So 1060 is root 3. We all know that. What is AB? AB is given 3 meter. That is provided to us in the problem over AC. So what will you get from here? The value of AC will be 3 over root 3. Correct? Or if you rationalize it, what will you get? You will get 3 root 3 over 3. So here you can cancel 3 and 3. So what are we getting? We are getting AC is equal to root 3 meter. Okay. All right. Okay. So that means the slide which is meant for elder children, that is going to have length root 3 meter. Is that clear? So basically here all you have to do is you have to identify the triangles in which you have to apply the rule or you have to apply the concept of trigonometry. After identifying the triangle, identify which side has been given and which side you have to calculate. Then look for the trigonometric ratio which is relating those two things. If you are able to find out that, you can easily do it. So please go through this solution. If you have any doubt, ask me right now. I will be more than happy to explain it. Please go through it. All right, is it done? Okay. Oh, oh, sorry. We use 1060 here. This has to be sine, guys. 1 second. There is some error here. This has to be sine 60 because sine 60 relate perpendicular and hypotenuse. Sine 60, which will be root 3 by 2. And here you will be getting, AC is equals to 6 by root 3 meter. Okay. If you rationalize it, you will get 6 root 3 by 3 meter. Okay. So 3 will cancel it 2 times. So you will be getting 2 root 3. Understood? That was human error. Because we were supposed to actually relate perpendicular and hypotenuse, and it's sine which gives or which relates perpendicular and hypotenuse. 10 relates perpendicular and base. I hope it's clear. So this solution is for your reference, guys. You can check here. You have two triangle. One triangle is ABC, in which if you apply this trigonometry, the concept that you studied, you will be getting AC is equals to 3 meter, and we also got AC is equal to 3 meter. The other triangle was XYZ here, and if you apply 10, if you apply sine 60 degree in that, you will be getting the length of the slide which is meant for elder children to be 2 root 3 meter. Clear? All right. So now we have the second problem. It says AB is a 6 meter high pole. Okay. So AB is this pole. The height is 6 meter. CD is a ladder. So this CD is a ladder. Let me mention here. This is ladder. Okay. At an angle of 60 degrees. So this is the angle they are talking about to the horizontal. Okay. That means that's an angle of inclination and reaches up to the point D of the pole that is given to us. Okay. So it reaches to the point D here. If AD is 2.54, so AD is given 2.54, we can calculate BD. Find the length of ladder and root 3 is 1.73 that you have to use. So basically, what do we have to find here? We have to find CD here. Okay. And what are we provided? Let me write here. We have to, CD means length of ladder. Actually, we have to calculate length of ladder. Okay. And we are already provided AB. AB is equal to 6 meter. Okay. And you are provided AD, that is equals to 2.54 meter. Right. So if AB is given to us, AD is given to us, we can easily calculate BD, right or not? Therefore, what will be BD? BD, which is the difference of AB and AD, that will be given by 6 minus 2.54. So what will you get if you subtract 2.54 from 6? You will be getting 3.46. Yes or no? Because if you add 3.46 to 2.54, you get 6. Because 6 plus 4 is 10, 5 plus 4 is 9, then 1 is carry. So you will be getting 0. Then 3 plus 2 is 5 and 1 carry. So it will give you 6. So the value of BD is 3.46 meter we have. So this is 3.46 meter. Okay. Now tell me a trigonometric ratio which involves perpendicular, because this side is opposite to the angle under consideration. So this side is going to act as perpendicular here. Okay. And this side is already hypotenuse, right? So tell me the trigonometric ratio which involves perpendicular and hypotenuse. We all know that the formula for sine of theta is perpendicular upon hypotenuse. So we can easily use that particular formula here. So if I talk about in triangle CBD, so if I talk about this particular triangle and I calculate sine of 60 degree, what will be the value? Sine of 60 degrees perpendicular by hypotenuse. So you will be having BD by CD. Okay. And what is sine 60 degrees? Sine 60 degree, we all know that is root 3 by 2. Okay. So root 3 by 2 is equal to BD. BD is 3.46 divided by CD. We are not aware of the value of CD. But yes, we are provided the value of root 3 that we have to use as per question. The value of root 3 which you have to use is 1.73. So we'll be using that. So what is CD? CD is going to be 2 into 3.46 over root 3. So I'm going to substitute the value of root 3. So I will be getting 2 into 3.46 over 1.73. Right? This 1.73 is going to cancel this 3.46 2 times. So you will be having CD is equal to 2 into 2 meter. That means you are going to have 4 meter. So this 4 meter is the length of the ladder that we are talking about. Is that clear? So the value of CD, which is representing the length of ladder, that is equal to 4 meter, nothing else. I hope it is clear to everyone. Please go through it and ask me if you have any doubt in this problem. Okay, done. All right. So you can see here the problem, the solution is for your reference. You went for sine 60 degree in that triangle. So that is 3.46 over CD. So CD is equals to what? After solving it, you can say CD is equals to what? That is 3.46 over sine 60. We all know sine 60 is root 3 by 2. They substituted that value. So they got 3.46 over root 3 multiplied by 2. This 3.46 will get cancelled by 1.73 two times. Okay, so 2 into 2 gave you like 2 into 2 is 4. So the length of ladder in this problem has to be 4 meter. That clear? Okay. Okay. So we have next problem. What does it says? It says a ladder placed against the wall such that it reaches the top of the wall of height 6 meter. So the height of the wall is provided to be 6 meter here, and the ladder is inclined at an angle of 60 degrees. So they are talking about this angle which is mentioned. Okay, how far the ladder is from the foot of the wall. So basically this is the value to be we have to find, or CB is what we have to find here. Clear? So to find or to calculate, you can say that is CB. Okay, CB means this is the uh, distance of distance of ladder from foot of the wall foot of the wall. All right, so here we are given angle that is 60 degree, and we know that the side which is going to be opposite to that angle will be called perpendicular, and we are fortunately provided the value of that perpendicular which is 6 meter. They are asking us what will be the distance or how far the ladder is from the foot of the wall. So they are asking us here this BC which is given to us. Okay, which we have to calculate. So tell me a trigonometric ratio which involves perpendicular and base. You have two trigonometric ratios which involves perpendicular and base. One of them is tan theta and the other one is cot theta. You can use any one of them. So in triangle ABC, okay, in triangle ABC, if I calculate tan of 60 degree, what will I get? Tan of 60 degree is going to be perpendicular, which is AB by BC because that is acting as base. Tan 60 we all know that is root 3, so you will have root 3 is equals to AB, which is 6 meter upon BC. Okay, so if we simplify it more, what will you get? You will get BC is equal to 6 over root 3 meter. Okay, we can simplify it more, so you will have BC is equal to 6 root 3 over 3 after rationalization. This 3 will cancel it 2 times. So what is the value of BC you are going to get? The value of BC which you are going to get is 2 root 3 meter. Understood? So 2 root 3 meter is the value of is the distance of the ladder from the foot of the wall. That is what they asked us in the problem. So you can see the problems are not difficult. It's only about extracting the information which is given to you in the problem, writing what is given, writing what you have to calculate, and then looking for the results which relate those two things. And if you are able to do that, you will quickly get the answer. Please go through it. Ask me if you have any doubt, guys. Okay, understood? All right. So they have done it in the exact same way. It's just that they have substituted the value of root 3 here, which is 1.732. So if you multiply 2 to 1.732, you get 3.464. So that's the answer. See, if you have time in your examination, and if the value of root 3 is given, then you should always substitute the value of root 3, and you should substitute the value of root 3 and simplify it as much as you can to be on safer side, because what happens is sometimes some teachers might deduct your half marks because of this reason only. So it's always better to be on safer side. If you have time, please substitute the value, simplify it as much as you can so that you do not lose even half mark. Okay. All right. So the next problem we have is a man wants to determine the height of a lighthouse. Okay. A plane is leaning against a wall, making an angle of 20 degree with the ground. So this angle they are talking about here, the foot of the plane. The foot of the plane is 3 meter from the wall. So they are talking about this distance. This is 3 meter. Understood? They are asking you what is the length of the plane. So they are asking you this value. Okay. This is the plane they are talking about. Okay. And this is lighthouse. This is lighthouse. Understood? Okay. So we are provided base. Okay. Because with respect to this angle, which is 20-degree, this side is going to act as base. You have to calculate hypotenuse, okay, which is actually the length of plane. So we will look for the trigonometric ratios which are going to relate them. Okay. So what do we have to find? We have to find AC, that is length of plane. You have to find AC, that is length of plane. Understood? So the solution is, we know that the trigonometric ratio which can relate base and hypotenuse, there are two trigonometric ratios. One is cos and the other is sec. You can use any one of them. It just, you have to make sure your calculation is correct, nothing else. Okay. So in triangle ABC, if I calculate cos of 20-degree, what will I get? Cos of 20-degree is going to give me base by hypotenuse, and base is BC, hypotenuse is AC. What is cos 20? Cos 20 is approximately, that is 0.9396. Okay. So that will be equals to BC. What is BC? BC is 3. And hypotenuse we have to calculate. Okay. So you have AC is equal to 3 over 0.9396. You can remove this decimal. So you will be getting 1000. Okay. One more zero. This 3 will cancel it. How many times? 3, 1, 3, 2. So you have you have 10,000 over 3132. So guys, please divide 10,000 by 3132 and let me know what you are going to get, so that we can get to get our final answer. Okay. Okay. So you are saying it's approximately 3.192. Okay. So the approximate value here you are getting is 3.192 meter. Okay. That means this is going to be the length of plane for this situation, which is given in the problem, to hold true. Is that clear to everyone? That's the answer to this problem. All right. So you can see here again they use cos. Okay. Again they use cos here. Cos theta is based by hypotenuse. Okay. So cos 20 is 3 over AC. Cos 20 is approximately this value. Then after solving it, you will get 3 over 0.9396. If you solve it further, approximate value you are going to get is 3.192 meter. Therefore, the length of the plane or ladder that they are talking about here is 3.192 meter. Understood? Okay. Now, important problem. This is important. Okay. Important. What does it says? It says a ladder rests against a wall at an angle alpha to the horizontal. When its foot is pulled away from the wall through a distance of A. So this is the distance, and it slides a distance B down the wall. So this is B. Okay. And makes an angle beta with the horizontal. Show that A over B is equal to cos alpha minus cos beta over sin alpha minus sin beta. Okay. So basically, we have to prove here. So let us calculate cos alpha, cos beta, sin alpha, sin beta, everything. So in triangle DAC, triangle DAC, if I calculate cos beta is based by hypotenuse. So that is going to be AC upon AD, which is the length of ladder. Okay. So I will be getting cos beta is equal to AC, which will be equals to A plus BC upon AD. Right or not? That's what I'll get. Let me call it our first result. Okay. And if I calculate sine beta is perpendicular by hypotenuse. So I will be getting CD by AD. So that's my second value. Okay. Now, if I talk about the other right triangle, in triangle EBC, if in this triangle I calculate, let's say, sine of alpha. So sine of alpha, before sine alpha, let us calculate cos alpha. Cos alpha. So cos alpha is based by hypotenuse. So you will be getting BC upon hypotenuse, which is BE. Okay. And BE. Okay. Let me call it result 3. And if I calculate sine of alpha here, what will I get? Sine of alpha is perpendicular by hypotenuse. So I will be getting EC over BC, EC over BE. Okay. Or I will be getting sine alpha is equal to EC can be written as B plus CD over BE. Okay. That's what I have. Fourth. Okay. Now I have to calculate cos alpha minus cos beta. Cos alpha minus cos beta upon sin alpha minus sin beta. So let us put the value. So now we have to calculate cos alpha minus cos beta upon sin alpha minus sin beta. Okay. So cos alpha is, and here you need to keep this one thing in mind, that this length that you have BE and this AD, they both are equal. Okay. So here the point to note is this BE, okay, is equals to AD because both of them represents length of ladder, okay, which is not going to change, that will remain same. All right. So what is cos alpha? Cos alpha is BC over BE. BC over BE. Understood? What is cos beta? That is A plus BC over AD, and I can replace this AD by BE. Okay. Right. What is sine alpha? That is B plus CD upon BE. Understood? Minus, what do you have? Minus sine beta, that is CD over AD, and AD can be replaced by BE. Understood? If you simplify it further, what will you get? You will be getting BC minus A minus BC upon BE. That will be equals to what? That will be equals to B plus CD minus CD upon, what will you get? You will get BE. Is that clear to everyone? Please confirm. You have cos alpha. Okay. Cos alpha is BC upon BE. Here, what do you have? You have cos alpha minus cos beta. So cos alpha is BC upon BE. So I substituted here. Understood? Cos beta is A plus BC over BE. I substituted here. Then in the denominator, you have sine alpha minus sine beta. So sine alpha is B plus CD upon BE. I substituted here. And sine beta is, if you look very carefully, that is CD upon AD. And AD can be replaced by BE. After taking LCM, you will be getting BC minus A minus BC here upon BE. And here you will be getting B plus CD minus CD upon BE. BE gets cancelled. CD gets cancelled. Here I think we can cancel BC and BC, right? So what do we have? We have minus of A by B. Correct or not? And here actually it should be minus of A by B to be able to show it. And that's exactly what we were supposed to show in this problem as well, guys. Clear? You can check here also for your reference. Okay. You can see here you have cos alpha. Here you have cos alpha minus cos beta divided by sine beta minus sine alpha. Okay, so the order is different. So that's what we got here. Just for your clarity, guys, do not get confused. You have cos alpha minus cos beta upon sine alpha minus sine beta is equal to minus of A by B. So this can also be written as, if you multiply minus sign on both the side, you can write it as cos beta minus cos alpha over sin alpha minus sin beta, that is equal to a by b. That is exactly same thing. Understood? Clear? So that's what you were supposed to show in this problem. Please go through this solution and ask me if you have any doubt in this particular problem. You ask me and I'll be more than happy to clear it. Right, understood? So you can check this solution. The solution is for your reference, guys. They have done it in exact same way. First, they considered the triangle ACD. Okay. In that particular triangle, what they did, they calculated sine beta, they calculated cos alpha, and they assumed the length of the ladder to be L units. Right. In the other triangle, which is EBC, they calculated sine alpha, cos alpha. Then they substituted the value in this expression, which we have to show. And after evaluating it properly, they got the answer, which is equals to a by b. Is that clear? So what we did in this session, we practiced few problems based on the inclined planes. And what we observe is the problems are not difficult, only the language might be a little tricky. So there are certain steps that you should follow to be able to do them without any error. First is, you should try to extract what information is given, write it down, like given these are the information or these are the points which are given. Second point is, you should write what you have to show. So that should be written in to show. And then you should see what is given, what you have to calculate, how you can relate these two things. If you can think of the identity or maybe trigonometric ratio or maybe some other concept using which you can link them, then you are done with this. Okay, so it's not difficult, it's just a matter of practice. The more you practice, the more confident you will get over this topic. All right, so that's it from this session. Thank you so much for attending.